Assalamu alaikum. Today we will start the second part of our chapter, Scalar Product, the analytic form of a scalar product. The objectives of this session are express analytically the scalar product of two vectors and calculate the cosine of the angle formed between two vectors. The analytic form of a scalar product. Given the vector u of coordinates x, y and v of coordinates x prime, y prime in the orthonormal system OIJ, we know that I scalar I is equal to the magnitude of I square, and the magnitude of I is equal to 1, so it's equal to 1. The same for J scalar J, and that I scalar J is equal to 0 since in an orthonormal system the x-axis and the y-axis are perpendicular, so I and J are orthogonal. If you want to express U scalar V using the coordinates of U and V, U is equal to xi plus yj and v is equal to x prime I plus y prime j. We will perform the distribution. We will obtain xx prime into I square, which is equal to xx prime since the modulus of I square is equal to 1, and xy prime I into j is equal to 0, and yx prime j into I is also equal to 0, plus yy prime to the magnitude of j square, and the magnitude of j square is equal to 1, so it's yy prime. So the analytic expression of the scalar product of two vectors, or the scalar product of two vectors given the coordinates of these two vectors, is u scalar v is equal to x prime plus y prime. The magnitude or the length of a vector, given a vector u of coordinates x, y, the length of u is equal to the radical of x squared plus y squared. Now, how to find the cosine of an angle formed between two vectors? Using the formula of the scalar product, which is u scalar v is equal to magnitude u times magnitude v times cosine theta, we can find cosine theta. It's equal to the scalar product of u and v over the product of the magnitudes of u and v. Now, if you want to express the cosine using the coordinates of the vectors, u scalar v is equal to x prime plus y prime over radical x squared plus y squared into radical x prime squared plus y prime squared. How to show that two vectors are orthogonal? We know that two vectors are orthogonal if their scalar product is equal to 0, which is equivalent in this case to x prime plus y prime equal 0. Let's go to the first application. Given in an orthonormal system OIJ, the 4 points A, B, C, and D. First, we have to calculate the scalar product of AB and AC and deduce the measure of the angle between these two vectors, which is BAC. To find the scalar product of AB and AC, first we have to find the vector, the components of the vectors AB and AC. AB 4, 0, AC minus 4, 4. Then AB scalar AC is equal to x prime plus y prime, which is equal to minus 16. Now cosine BAC is equal to AB scalar AC over the magnitude of AB times the magnitude of AC, which is equal to minus 16 into 4 over 4 times 4 radical 2. This is equal to minus radical 2 over 2. Then BAC is equal to cosine minus 1 minus radical 2 over 2, which is equal to 3 pi over 4 radian. Second, show that the triangle ACD is right at A. If you want to show that this triangle is right at A using the scalar product, then we have to show that AC scalar AD is equal to 0. So, first, we will find the components of the vector AD, and we already have the components of the vector AC. AC scalar AD is equal to x prime plus y prime, which is equal to 0. Then AC and AD are two orthogonal vectors. Then AC line and AD line are perpendicular, hence ACD is right at A. A second application. In an orthonormal system OIJ, given the points A, B, and C, and XC is equal to M. 1. Calculate M if ABC is right at A. So, as we did in the first application, if ABC is right at A, then AB scalar AC should be equal to 0. First, you find the components of the vectors AB and AC, and the vector AC, the abscissa of AC, is found in terms of M. So, since AB and AC are orthogonal, then AB scalar AC is equal to 0. So, x prime plus y prime is equal to 0. We have an equation with one unknown, which is M. Then we can find M. M is equal to 2. 2. Deduce that ABC is right isosceles at A. We already know that it is right at A. So, right isosceles should prove that AB is equal to AC. Now, AB is equal to the radical of xab squared plus yab squared, which is equal to 5. And you should do the same for AC. No, the vector AC, the components of AC are now 2 plus 2, 4, and 3. So we calculate the magnitude of AC. It's equal to 5. Since AB is equal to AC and ABC is already a right triangle, so ABC is right isosceles at A. This is the homework for next time. Thank you.